Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Haziq bin Zainudin, Matric ID MA18122 from Group 6. Today, our group is going to present about Experiment 5, which is Pelton Wheel Turbine. For introduction, the Pelton wheel turbine is a constant pressure or impulse water turbine. The water heat is really high in this scenario. A Pelton wheel is made up of a rotor wheel. The turbine's rotor is made up of a circular disc with a number of double spoon-shaped buckets uniformly spaced around the perimeter. The water comes from a nearby reservoir. The nozzle of this type of turbine converts the available hydraulic energy of the water into kinetic energy at atmospheric pressure. Each nozzle conducts the jet along a tangent to the circle, passing through the bucket centers. Each bucket has a splitter that separates the entering jet into two equal halves, and after running around the smooth inside surface of the bucket, the water exits with a relative velocity almost opposite to the original jet. The water jet changes in velocity as it passes over the bucket, exerts tangential force on the wheel, forcing it to spin. As the result, the shaft movement turns hydraulic energy into mechanical energy. For the background for this project, the UMP Liquid Mechanics Lab allows students to experiment with the Pelton wheel turbine. The goal is to expose the students to the Pelton wheel turbine's functioning component by varying the rotating speed while maintaining consistent weight and stream flow circumstances. A barometric weight is used at the channel and outflow. Next, the information gathered will be analyzed and studied in order to arrive at a final conclusion that will validate the theory used for Pelton wheel turbines. And for the result, the findings of this study will provide students with a framework for selecting the best Pelton wheel turbine. The experiment is on a small size, but it employs the same principles as the Pelton wheel turbine used in real life. And the problem statement is the interest in the source of water supply from people all around the world has made energy from flowing water renowned. As the result, the research into the source of water supply from the Pelton wheel turbine should be conducted through testing. The Pelton wheel turbine test will reveal the effects of changing rotational speed while maintaining a constant pressure factor and stream rate on yield force and efficiency. And for the objective of this project, first to determine the performance of a Pelton wheel turbine, and second to study the characteristics curve of a Pelton turbine operating at a different fluid flow rates with high head. Torque against turbine rotational speed curve, power output against turbine rotational speed curve, and turbine efficiency against turbine rotational speed curve. And for the scope, only a lab-scale Pelton wheel is used in this experiment. In comparison to a full-size Pelton which can create 100 million watts, this wheel would only create a little amount of electricity. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Hasbullah and my ID is M818126. So today I'm going to continue to present about the theory, method, and also the procedure. So we go through for the theory first. So as we can see in the picture, the Pelton turbine is a hydraulic impulse turbine in which one of or more water jet hit the bucket on wheel. The force produced by the jet impact at the right angle to the bucket generates a torque that causes the wheel to rotate, thus producing the power. The Pelton will need a source of water in order to run. If the head of the water is known along with the flow rate, then it is possible to find the best size of the wheel to use, how fast it should rotate to obtain the maximum efficiency, and what power it is like to develop. The velocity in the jet can be estimated by using the known fixed head. The diameter of the jet can be found from the known flow rate. A suitable wheel diameter can be chosen in the relation to the jet. Typically, the wheel would have the diameter of 10 times of the jet. The best speed of rotation may be selected such that the speed of the bucket is approximately half that of the jet speed. So next we go to the method and also the procedure. So this is our experimental setup. So we have a pressure gauge, sphere valve, inlet pipe, spring balance, tachometer sensor, and also the turbine. So we go through one by one for the procedure. So firstly, we need to prior to the beginning, every one of the association of the water are checked. So there are it has no spillage in the pressure driven seat. Second, we need to, the lens valve is totally shut, which means we need to turn it completely clockwise. After that, start the water driven seat and progressively open the control valve while opening the lens regulator until the seat stream is at the most extreme and the lens valve is completely open. Then the hydraulic seat is utilized to gauge the underlying stream reference. The bay pressing factor is noted. After that, the tachometer is utilized to quantify the limit of the turbine. The tachometer is set against the clear glass at the rear of the turbine and it is utilized to identify the intelligence sticker on the drum. After that, the tachometer is perusing wheel change somewhat on schedule. The normal rotational spin is assessed throughout the span of the couple of moments. Then number 7, the volumetric flow rate is dictated by stopping up the channel at the lower part of the seat with the channel section. And the number 8, the waterline on the seat is noted. The clock is begun when the waterline arrives at 0 liters and it is halt when it arrives at 10 liters. The volumetric flow rate is gotten by isolating the 10 liters. Last but not least is the trial is rehearsed with lessening the RPM. I think that for me. Thank you.
Hi everyone, I'm Chandra Sekar from Group 6. Now I would like to explain on result and discussion. The first result is on turbine characteristic curve, that is fully open, constant at 0.2 bar and constant at 30.91. The second table is about power curve with pressure at 0.2 bar, Q equals to 18.75. Now let's see the graph and discussion. This graph is basically on efficiency versus rotational speed. The performance value is 42%, which is lowest in the experiment with the rotational speed value of 286 rpm. However, when the value of rotational speed is at its maximum, which is 61% and 534 rpm, the performance is at its highest. The second graph is on fault versus rotational speed. The line is right skewed in the graph of power out versus rotational speed. The rotational speed is 470 rpm and the highest power output is 3.2 volt. Finally, at 760 rpm, the power output dropped to zero, showing that a higher rotational speed does not always imply a high power output. About the conclusion, we can conclude that